Hi, all, this is Mr. Yeager for chemistry. Into the the second to last gas law that we're going to be doing. This is called the combined gas law. And it's basically, as it sounds, we're putting together all of the other ones that we've done, where we've done Boyle's, Charles, and Gay-Lussac's, and kind of just combining all the different ideas of the direct and indirect or inverse relationships with pressure, volume, and temperature. So, I mean, all we basically have here is there's the formula for it, okay? You can see PV over T equals PV over T. Again, you can kind of see all the different gas laws present. We got Boyle's, if I change the color so we can actually see it. We got, come on thing. We got Boyle's, I'll try this again. We got Boyle's, we got Gay-Lussac's with P over T, and we have Charles with V over T. So, again, in obviously real situations, we have multiple variables changing, and so that's what we're just playing around with here. So there's not much else to say about it. There's no graph with it or anything. We technically are saying mass is staying the same. So again, you've been seeing that in the other ones, but we don't really, really don't mess with mass too much, but that is a point to make. But let's go ahead and try out a few problems that I have. I have to switch over to this. So let's just do 3 problems. So with this, the big thing again is just making sure you put all of those numbers together correctly and that we have correct units that match up on both sides, okay? So I will say the first one is immediately a bit difficult, okay? It says you have a sample of sulfur dioxide gas. It has a volume of 652, temperature at 40, and pressure of 720. So we do have all the pieces here, okay? That would be 1, 1, 1. And it says we're changing it to STP, which means T2 is equal to 273 Kelvin, and P2 is equal to 1 ATM. Well, because I'm in ATM and Kelvin, I need to adjust at least this pressure for the 720 millimeters of mercury. So if we recall, 1 ATM is equal to 760 millimeters of mercury. I can do 720 millimeters of mercury, 1 ATM on top, 760 on the bottom, and I get that this is equal to 0.95 ATM is my pressure 1. So now I can go ahead and get this all in. I don't have to change the volume. I can leave volume as milliliters. It will just come out as milliliters at the end. So my formula is P1 V1 over T1 equals P2 V2 over T2. So when I set this up, I have 0.95 times 652, that's the volume, over, and now I have to do 273 plus 40, which is 313. And then that equals, on the other side, new pressure is 1. I'm trying to solve for the volume. And then this is over 273. You can once again do the cross multiplication. I usually don't do that as much on this one. Usually I solve this whole side of the problem. But let's go ahead and continue with the cross multiplying. That might have helped out a lot of people. So basically just multiply both things to the other side from the bottom. Basically multiply the opposites with each other. So you get 0.95 times 652 times 273, and that equals 313. Times 1 times V, and then you can see I'm going to divide by 313 to the other side. All right, and that'll give me my volume. And my volume comes out to be 540 milliliters. All right, so I mean, I guess you could say it gets a little more difficult just because you have a lot more numbers. But just kind of make sure you get everything together well. The math is very similar. Let's look at number 2. You have a sample of nitrogen, 2 liters, 756, 0 degrees. So again, these problems do a good job of kind of keeping everything together. You know all 3 of these numbers are going to be together. There's your volume, there's your pressure, there's your temperature. And again, I know I'm doing combined because I'm being given so many numbers. I'm being given 5 numbers. I'm trying to solve for the last one. This is the final volume. Sorry, I put 1s back there. and this is the final temperature, and I want to find the final pressure. So if I set this up, I'm doing P 756. I don't need to change it this time because I don't have the other pressure unit, so I can leave it as millimeters of mercury, times 2, which is the volume, over 0 degrees, that's 273. That's the formula with Kelvin. On the other side, I have pressure, I don't know, volume of 4 over 137. Okay? I can then cross multiply. Again, I think that's probably the safest bet for a lot of people. Times 2 times 137 equals P2, 4 times 273. I'm going to divide the 4 times 273 to the other side. And I get a pressure, a very, very low pressure of 18.8 millimeters of mercury. I think that always makes me a little worried. It seems very, very small, but we are decreasing the temperature 140 Kelvin, so that's understandable, and we're increasing the volume, so pressure is definitely being affected, so it's dropping quite a bit. Let's try one more. A helium-filled balloon has a volume of 50 at 25 degrees and 10.08 atm. What volume will it have at 0.85 atm and 10 degrees Celsius? So I'm going to take this a different way. I'm going to get the temperatures first. So 273 plus 25 is 298. And then 10 degrees would be 273 plus 10, so that would be 283. All right. All these numbers go together. PV, so P 1.08, I can see ATM, I don't need to convert anything, times 50 divided by 298 equals new pressure 0.855 times V over 283. Cross multiply, 1.08 times 50 times 283 equals 0.855 times 298 times V, divide out the 0.855 times 298. And solve. Volume is 93.2 liters. Again, find that unit. And that's it. That's how we do the combined gas law. All right, and we only got one more to go. Thank you.